Hello everybody, welcome back. So today we will work on another question. Probably you can see on the screen. I posted this question 2 days back. If you tried, great. If did not, then you can stop the video at any time. Try it yourself. If you can solve it, that would be great. You can share with me in my post or under this video in your comments. So your views. If not, then step by step you can go through this video and see this wonderful solution. It's a really nice solution. Graphically, you can solve this question and get the really nice answer 1.32 or 1.33. So that's the answer for the solution if you're putting it back. But algebra is not working in this question. That's the important part. Algebra is not working till the end. So we are using a lot of strategies in there. And the second part of this video will contain and other part of it. So I will try to go through all the theorems or all the stories or all the you can say the methods behind it, series behind it. So we will go through all those things one by one. So let's start this question. So let's solve this question today. It's a log base 2 of x is equal to 1 over 2 power x. So we know how to work with these kind of questions. I can rewrite this like log base 2 of x is equal to 1 over 2 power x, because 1 power x is just 1, so I don't need to worry. And I can bring this 2 power x on the other side, 2 power x into log base 2 of x is equal to 1. I can simplify it. So, and because a into log base b of x is equal to log base b of x power a. That's the logarithmic law. So I can bring the coefficient as an exponent. So then I can change it. It's a log base 2 of x raised to power 2 power x is equal to 1. So in short, what I can say here the exponent laws are going to work. Power to power is multiplied, so it's a log base 2 of x raised to power 2x is equal to 1. What I can do now, knowingly I'm making this change, so I can bring 2 down from 2x. So 2 is down, log base 2 of x power x is equal to 1. So if I'm at this point, then I'm very close to another type of the function. So now I can move that 2 on other side. So that 2 is going to be log base 2 of x power x is equal to 1 over 2. If I will change the definition of the log to change it to an exponential function, so then my function is going to look like 2 raised to power 1 over 2 is equal to x power x, or I can say x power x is equal to square root of 2. This is known as a transcendental function. Up to this point, your algebra is working, and after that, algebra is not going to work how it used to be working. So this is a transcendental function. I can write it here. It's a transcendental equation, you can say, and can't solve using elementary algebra. So which method I would use then? So I'm going to use Lambert W function. So we would use Lambert W function. So how this is going to work? So first of all, I will take log of this equation number 1 on both sides. Take natural log of equation number 1. So what would happen to this then? X is going to, let's write it full first. X power n is equal to natural log of x power x is equal to natural log of root 2. So that's going to be, I can bring x down. X into natural log of x is natural log of root 2. Now let's say I'm going to suppose a variable. Let's say my natural log of x is equal to t, and then x is equal to e raised to power t by definition of log. So I have to pick this up. I can say this is my equation number 2. So if I will substitute these values, it would be e power t into t is equal to natural log of 2. And if I'm going one step more, so t times e power t is equal to natural log of 2. So this is going to be a Lambert W function where I can use it, and in Lambert W function we are saying this is equal to z, let's say. So this value is equal to z or z, and from here we can go wz is equal to t. That's a Lambert w function value of this natural log of 2 is your t value. That's the actually the part of that solution. So t is equal to w of z, and z is w of natural log of root 2, which is equal to w of 0.34 and 657 if you will go with the decimal value. So this is my t value. Now how to find Lambert W function? So for Lambert W function we need to use function we are using uh, the series expansion because which is working for small values like z absolute value is less than equal to 1. So here we have the value, this is 0 point something, so that's less than 1. So how this value is working, so w z is equal to z minus z squared plus 3 over 2 z cube, and again it's minus 8 over 3 z4 and so on. This is also known as Maclaurin series, which is coming from Taylor series. As I said in the beginning, so I will go over those series at the end in the second part of this video. So but if I will substitute these values in here, what would happen then? This is equal to 0.34657 plus 3 over 2, same thing, 0.34657 power 3, and minus so on. If I will solve all these things together, I think I missed one part. Go over this part. Okay, so this is going to be z squared, so that's 0.34657 squared, and minus 3 over 2 into 0.34657 cube, and minus so on other terms. So more terms are going to reach to more decimal places. If you will use calculator to simplify all this, you will reach to a number that's going to be 0.2888994, something like this. So this is your wz value, or you can say this is your t value. So t is equal to 0.2888994. So I found my t value. So now because I know my t value, what's a t now? T is e power. So your x is e power t. So your x value is e power t. If you remember in the beginning, I will show you once again. X is equal to e power t. We already supposed in number 2 equation. That's right there. So substitute the value. This is e raised to power 0.28889 and 4. I'm going to simplify it by using calculator. So your answer is going to be 1.33495. So this is the answer for this solution. If you're going to substitute this answer back in the equation, then left side and right side are going to be balanced. You can check by graphing method too, this is working. But this is only working if we are using Lambert W function, and then we can solve it. There is also another part you can do here. I can suppose my x is 1 over 2, then I can write 2 as 2 power 1 over 2. Somehow I can manage. So maybe my answer is 0.5, but if that 0.5 is working in there, then 0.5 is not working in your original equation. So answer is 1.32. So that's why we are reaching to that answer by using this different approach to this question. I hope you like it. Your question is done at this point, and in the second half of this video, so we are going to go over all those series which I used in this question. So the contest behind the solution. So what's behind the solution? So first of all, let's have a look at Taylor's series. So Taylor series, it's a way to represent a function. So as an infinite sum of the terms calculated from the values of its derivatives at a single point. So we are using derivatives in Taylor's Taylor's series, sorry. So my fx is equal to, so a is that point first of all. So fa plus f dash a into x minus a plus f double dash a over 2 factorial. 2 factorial means 2 times 1. You have to, if it is 3 factorial in the next term, so that's going to be 3 times 2 times 1. Hopefully you know what factorial means. X minus a squared, then third derivative of f at a over 3 factorial into x minus a power 3. So this is known as Taylor's theorem. So if a is 0, then it's called Maclaurin series. If I'm checking all these derivatives and this series value for any function at 0, then it's known as Maclaurin series. So it's a subpart of Taylor's series. So it's a powerful tool in the calculus and analysis because it allows in the approximate complicated functions using polynomials. So from the polynomials we can define the complicated functions by using these series. So what Maclaurin series look like then? It's a special case of Taylor series, as I said before. So centered at 0. So it expresses the function as an infinite sum of its derivatives at x equals 0. So fx is equal to, that's the function f0 f dash 0 and times x, f double dash x into x square over 2 factorial, and continuously we have this third term. So or you can also write a summation if you want to. So also exponential function. So e power x can be represented by using this series. So you can write 1 plus x square over 2 factorial, x cube over 3 factorial, so on. That can be used for this. E power x derivative is also e power x. I hope you remember that. So sine x can be represented by using this series. You can check that out too. X into x cube over 3 factorial, x5 over 5 factorial. Series is different, but again, this is how it look like if you're going for a sine function. We can also write cosine function. That's also another example. You can check these terms. This is working for that function as well. It's useful for to find the value of the fx near 0. So if we are looking for value of the function near 0, so then these series are awesome. Now let's go to our how it's related to the Lambert W function which we used in that question. So we are coming deep from Taylor's theories and Maclaurin, then we came to Maclaurin. So now all these things are working for us for Lambert W function. How they are working? Lambert W function satisfy wz is equal to wz into e power wz is equal to z. So this is what we wrote over there. So our t was equal to t into e power t, if you guys remember. So for very small value of z, wz is also small. So we can expand wz as a power series of z using Maclaurin series. So wz is equal to a1 into z, a2 into z2, a3 into z cube, and so on. I can also write as a summation. So plug into wz e power wz equal to z. If I'm going to substitute that in, then you can also write z value as summation of these two series product. So matching the coefficient, if you will expand these things, if you're going to match the coefficients for z, so you can find cn value, which I wrote in the beginning, in here cn in the first series. Result would be wz is equal to z minus z square plus 3 over 2 z cube 8 over 3 z4 125 over 24 z4. So this is the series going to develop, and which is matching with your Lambert W function, exact word to word, number to number. So that's why we are using this value for our t value in that question. So this is a little bit behind this question, which information can we use to solve it. I think this is a so advanced of the mathematics. If you are the beginner, or you are a secondary school student or university student, probably it's a too much information for you, but that doesn't mean you don't need to, you can't understand it. It's not hard, but you can use any resources. A lot of things are available on the internet in these days, so you can go through all these things to solve such questions. And it took us longer time to do it, so please watch it and try to understand it. Share, comment if you want such more the question solutions videos. That's going to be a boost for our energy to make such more videos. That would be great. And thank you very much for watching us till this point, if you're still watching it. And take care, have a nice day. And please like, share, and subscribe our channel for future upcoming videos and such solutions. Thank you. Take care.